I'm Professor Rad, and this is Precalc video 1-3, inside transformations. In our last video, we talked a little bit about the difference between inside and outside transformations, but we'll do a real quick review of that before we begin. And then we'll do some examples of inside transformations on functions. So a transformation on a function is going to be either a stretch or a shrink, and a shift, maybe up or down, left or right, and also a reflection. So we can identify outside versus inside transformations by where algebraically the action is happening. So outside transformations have the amendment, if you will, happening outside the function itself. So here we have the +2 being added outside the function f of x. Here the +2 is being added after we've done the squaring, so after the function part. And similarly here we have 2 times, and then we have the function piece, the absolute value of x. So these are the outside transformations, the types of things we looked at in the previous video. In this video, we're going to look at inside transformations. So now notice this +2 is happening inside the parentheses of the f of x. So the +2 is happening inside before the function has a chance to happen. So like with the x +2 and then squared, that +2 is happening first, and then the function happens afterwards. The squaring part happens after. So that makes this an inside transformation. Similarly, this 2x is inside the absolute value bars, so that ×2 is happening inside the function. In the last video, we talked about some guidelines for outside functions or outside transformations, how that affected our function. So here we have some general guidelines for inside transformations. So if you'd like to pause the video here and write those down for reference, you may do that. Or you can write them down as we talk about it, whatever, floats your boat. So here, inside transformations are going to have a horizontal change, which makes sense. Outside had a vertical change because we were changing the y component of the expression. Now we're changing the x component of the expression. So that's going to have a horizontal impact. This next part is the weird part. So horizontal changes or inside changes work against your intuition and the order of operations. What that means is if we have multiple horizontal changes to make, we're going to follow them in the opposite order of operations, and we're not going to do what we want to do. We kind of do the opposite of it. So remember with a vertical transformation, if we had a +2, we thought that's going to be a shift up. So our intuition tells us if we're adding 2, that ought to be a shift to the right if we're doing horizontal changes. So this is what I mean by we work against intuition. If we add 2 inside the function, that's actually going to be a shift to the left instead of to the right. So it works against what you want it to do. Similarly, if we're multiplying or dividing by something, it will have a horizontal shift. But if I multiply by something like 7, instead of stretching it, it's going to shrink it. And if I divide or I multiply by something like 1/2, instead of shrinking horizontally, it's going to stretch it. So it works the opposite of what you expect it to do. So when we do a few examples, we'll see why, arithmetically or algebraically, why that's occurring. But in general, it's good to remember that vertical changes are the way you want them to be. Horizontal changes are the opposite of what you want them to be. So as before, we're going to do 3 examples. One of them is going to be based off of the cubed root function. So if you want to take a moment and sketch out the cubed root function for reference, that'll be great. And then we'll do 2 more examples after that with some funky, weird looking graphs. So let's do the first example with the cubed root, and we're going to change that by shifting it by 2. For this example, I've listed kind of an amendment of our inside changes over here on the left here, just kind of for quick reference. I've also sketched the graph of f of x equals the cubed root of x, because we've been asked to graph the cubed root of x +2. So if you want to take a minute and copy any of this down that you think is going to be helpful, feel free to do that. So as before, in order to help us create our coordinate plane, we need to think about the transformation and its impact that it's going to have on our basic or base root function here. So in this case, we have a +2 that's happening underneath the radical. So it's happening inside the function. So that's telling us it's going to have a horizontal change. So that means we're not going to have to change our vertical axis at all. We're just going to change the horizontal axis. Now we have +2, which is a shift, and our intuition is telling us it's probably going to go to the right, which means that's wrong because we go the opposite. So this +2 is going to result in a shift left. So I find it helpful for me, at least while I'm getting like used to the horizontal changes, to put it in my brain to help write it down each time so that I can remember this is going against what I want it to do. So what that means, the impact that's going to have on our set of axes here that are currently going from about -10 to 10, is I want to shift that left by 2. So I'm going to go from -12 up to 8. That's what I'm going to do for my axis. The vertical axis, like I said, is going to stay the same. Probably should have done that a little bit better. So let's redraw that. There we go. Okay. So that's my new grid that's going to go from -12 to 8. Then to transform this function, we just move every point to the left by 2. So we're going to pick up these key points that are easy for us to identify. And then we're just going to shift each of them to the left by 2. So this point that's at -8, -2, we're going to have to move that over 2 spots to -10. So I'm going to move that one over here to -10. This one that's at -1, -1, when I shift it over, it's now going to be at -3, -1. 1, 2, 3, -1. The point 0, 0 is going to shift over 2 to be -2, 0. 1, 1 shifts over to, which is a -1, 1. And then 8, 2 is going to shift over 2 spots to 6, 2. Once we have those points plotted, then we can connect them in the same order that they were connected in the original. So we have a little cube root shimmy going on here in the middle. And making sure to include the arrows to indicate, continuation in either way. This is bothering me, so I'm going to fix it. There we go. And there we have it. That's our transformation shifting left by 2. And if we compare this new function to the original, it looks like, in fact, what we did. Right? It looks like we moved everything over by 2 spots. Now, if I want to examine why this is happening, why we have to do this shift to the left instead of shifting to the right, let's think about what's happening here. So if I have g of -1, g of, let's do g of -2, and we'll do g of -3, just so we can see what's going on with those 2 points. If I think algebraically what's going on, that's the cubed root of -2 plus 2, which is the cube root of 0. And with -3, if I put -3 up in there, we get the cubed root of -3 plus 1, which is the cubed root of, plus 2, where 1 came from, which is the cubed root of -1. So if I see, if I were to write this in terms of my function f of x, this is the same as f of 0, and this is the same as f of -1, because f just took the cubed root of it. So by having that +2 in there, we're basically having to accommodate that now initially we're starting to the left so that we can move to where we want to be from the original function. That's essentially what's going on here, so that g of -3, which is this point here, is the same as f of -1, which was this point here. So we have to shift left in order to make that accommodation in the y values. It's kind of funky, but that is more or less why we're going to be doing this like opposite nonsense for how the transformations horizontally are going to be working. So let's do an example where we have like a stretch or a shrink and see how that's going to work horizontally. For our second example of inside transformations, we're going to be graphing g of x equaling f of 2x. So again, we have an inside transformation because the 2 times x is happening inside the function. So that means we're going to have a horizontal transformation. Since we're multiplying, that means we're going to have either a stretch or a shrink. And because it's horizontal, it's inside, it works against what we want it to do. Instead of stretching by 2, this is actually going to compress. Okay, so we're going to shrink it in half. So this times 2 means a horizontal shrink by, and I'm going to write 2 inverse here, which is 1/2. I'm doing this so when I look at my notes later, I know where 1/2 came from. So if this had been f of 3x, then we would be doing 1/3. If it had been f of 2/3 x, then we would be doing 3/2. Okay, so you want to be using a reciprocal here to help you figure out the change that will occur. So, excuse me, caught my throat there. So this is our function, f of x, that will be transforming. Excuse me, my goodness. So we're going to take this function and we're going to shrink it horizontally by half, which means we're going to be compressing it. So to help us achieve that, to figure out what coordinate plane we need, let's look at the extremes. So the furthest left point and the furthest point to the right, and see what happens to those. So here we have -3. If I cut -3 in half, that gets me to -1.5. And if I have 3 and I cut that in half, that's going to bring me to 1.5. So when I create my plane, instead of going from -3 to 3, I have to go from -1.5 up to 1.5, sorry. My vertical axis isn't going to change at all because nothing changes vertically on this transformation. So I'm going to set up my axes accordingly. I don't know why I went so wide there, but let's see. So we have up to 4. All right, there we go. Not a very big graphing space for this problem. Then, as we did with the shift, we're going to do the same thing to our x values here. So we are going to cut each x value by half. So for instance, when I'm here at -3, 0, I'm going to divide this x value by 2. So that makes it -3/2, which is a -1.5. So my new point is -1.5, 0. For this point here, which was at -1, -1, we're going to keep the y value the same, but the x value gets cut in half. So half of -1 is a -1/2. So our new point is -1/2, -1. Then this point 1, 0, the y value stays the same, but the x value is going to turn into a half. So we have the point 1/2, 0. And then we had the point 3, 3, and it was an open point, and y stays the same, but x we're going to cut in half. So half of 3 is 1.5. So our new point is 1.5, 3. And then we connect the points in the same way they were connected originally. So if we can compare our transformed function to the original, it definitely looks like we took this graph and we cut it in half or squished it in half, right? We sort of compressed it horizontally. All right, so that's our horizontal transformation. We did one shift and we did one, in this case, shrink. So let's do an example that combines both shifting and stretching or shrinking. So combination of transformations horizontally. Now it's time for our final example. So we have this delightful function f of x here graphed. If you want to pause to graph that for reference, you may do so now. Okay. And then what we're going to do with that function is we are going to graph f of half of x minus 3. So now we have two inside transformations taking place because we have this 1/2 x and we also have this minus 3. So we already know inside transformations are going to have a horizontal impact and they work against intuition. So what that means is this 1/2 is going to be a stretch instead of a shrink. And this minus 3, instead of going left, is going to go right by 3. So we already have that part down because we've done some examples like that. But the weirdness continues and gets even worse because not only does it work opposite intuition, it works opposite the order of operations. So ordinarily, if you follow the order of operations, you have to do anything that multiplies before you do anything that adds or subtracts. And that's what we did in the case of the vertical transformations. We did any scaling, any stretching or shrinking first, and then we did shifting. For horizontal transformations, we do the opposite. So instead of dealing with the stretch or shrink first, we're actually going to do the shifting part first, and then we do the stretch and shrink. So not only does the type of transformation work weird, but the order of the transformations is weird as well. So let's write out what our transformations will be. So first, we're going to have to deal with this minus 3 because in the order of operations, multiplying comes before subtracting. So now subtracting, that impact is going to happen first because it's backwards. So first, we're going to shift right by 3. And then second, we get to deal with this 1/2 x. So instead of shrinking by 1/2, we're going to stretch by the reciprocal. So the reciprocal of 1/2 is 2. So we're going to stretch horizontally by, and again, I'm going to write the reciprocal notation here just so I have it for reference in my notes. You don't have to write that part, but we're going to stretch horizontally by 2. In other words, we're going to double the x values. Now, in the last video, we said our ultimate goal is to go directly from the graph, following these transformations to our final graph. That's where we want to be at the end of all this. But right now, we're still learning it. So if it helps us to create a table of what's going to happen to each of these points, we should do that. So that's what I'm going to do while we're learning this. So I'm going to start out with my original point. Then, following the order of these, we're going to shift it first. And then we're going to do a stretch. So I'm going to write down all of my original nice points. We have 1, 2, 3, 4, 5 of them. So we have the point -3, -2, -2, 0, 0, 2, 2, 0, and 3, 2. So first I'm going to see where each of these points is going to go after I shifted to the right by 3. So -3, -2, when I shift to the right by 3, 1, 2, 3, is going to be at 0, -2. -2, 0, when I shift this one to the right by 3, 1, 2, 3, is going to be at 1, 0. And so on. So 0, 2 is going to become 3, 2. 2, 0 becomes 5, 0. And 3, 2. 1, 2, 3. So that's 3, 4, 5, 6, 2. So we see where each of those points are going to be shifting to. Then after we do the shift, we have to do the stretch. So we're going to take these newly shifted points and we're going to stretch them. In other words, we're going to double each of the x values because we have to multiply by 2. So the y values will remain unchanged. This time the x values are going to change. So 2 times 0, so we're going to do x times 2. That's my reference here. So 2 times 0 is 0. 1 times 2 is 2. 3 times 2 is 6. 5 times 2 is 10. Oh, goodness. And then 6 times 2 is 12. Alrighty, so we've done the shift and then we did the stretch. And now let's see what that looks like visually. And hopefully it looks like we did what we said we did. So in this case, my smallest x value is 0 and my largest is 12. We didn't change the vertical axis, so I can keep that the same, but we're going to need a long x-axis for this one. So vertical axis, more or less the same. Horizontal axis, quite a bit longer. I mean, we stopped at like 4, we have to go up to 12. So 2. I made it. 2, 3. All right. Now we're just going to graph those new points that we created. So 0, -2, 2, 0, 6, 2, oh my goodness, 10, 0, and 12, 2. Okay. So now we've got all of our points graphed and we connect them in the manner they were connected. So all of these points were connected with straight segments. So that's what we're going to do here. And then we include the arrows because we had arrows here initially. So this is f of 1/2 x minus 3. So it definitely looks like there was a stretch that took place, and it looks like we've shifted it to the right a little bit, yeah, because this point here was at 2, so we've definitely done a shift to it. Okay, now as you'll recall, our goal is to go from initial graph to final graph without having to write this table. So if you want to write the table, absolutely feel free to do so. Could get you some partial credit if you make a mistake. But if you don't want to write the table, if you want to just go from one graph to the next, then you need to write down what your transformations are so that I know, the order that you're doing your transformations in, and then you can create your graph. So let's go through what that would look like, what that process looks like. So first I'm going to shift to the right by 3, and then I need to double the x. So this point here that was at -3, -2, I go to the right by 3, 1, 2, 3. The x value is 0, so double 0 is 0. So that's where my point goes, -2, 0, -2. That's this point here. This point at -2, 0, I shift it to the right by 3, 1, 2, 3. So now I'm at 1. I double the x value, so it becomes 2. So 2, 0. This point here at 0, 2, I shift it to the right by 3, 1, 2, 3. So now I'm at 3, 2. And then I double the x, so that's going to take me to 6, 2. Just gonna give myself some more space here, 5. Just give myself a little bit of room. So you can see where these are going. So we have 6, 2, the next one. Then if I'm looking at this point, I go to the right by 3, 1, 2, 3, and I double the x. So the x value here is 5. So when I double it, I'm over at 10. And then for this one, I was at 3, 2. So I'm going to shift to the right 3, 1, 2, 3. And then I double the x. So I double 6, and that's where we're getting our 12. So you can see more visually, I guess, what's happening to each of those points as we do that transformation. So far we've talked about vertical transformations that are stretching, shrinking, or shifting, and we've talked about horizontal transformations that are also stretching, shrinking, and shifting. So in the next video, so this is our third transformation video, we'll be talking about reflecting. So what happens if I want to, instead of like shift, what if I wanted to flip this over the y-axis or reflect it over the x-axis? What would that look like? How would I do that? So that's where we're headed in the next video. Hopefully this helped you out with some inside transformations, and I'll see you in the next one. Bye.